So good morning, everyone. Can you hear me loud and clear? Yes. Awesome, awesome. How are you doing this morning? Good. My name is Jeff. I just fly from Taiwan to Munich. I think arrived on Tuesday. So I'm still in a little bit jet lag. And on the next day, just yesterday, Wednesday, I just fly from Munich to London. So, oh my God, the temperature changed so much, like from 23 Celsius to like a -4. And I think this morning is around -2. It's really refreshed my impression about London. Oh my God. So today, what I'm going to talk about is about LLM. The topic is talking about stop treating LLM like RESTful API. How many of you are familiar with the LLM? Oh my God, it's getting more and more people understand LLM, so I need to be very cautious about what I'm talking about. There are a couple of questions I want to get started with this talk. So please follow me. First of all, whose company is currently doing AI model training? Please raise your hands. 1, 2, I think 2 people. Maybe 3, some fine-tuning, something not really from the ground up, right? Just fine-tuning, all right. Second question, whose company is doing AI inference workload? The inference can represent just API calls to the models, ChatGPT integrations. So I saw many people raise their hands. So you see that at the very beginning, you think about, all right, we need a GPU car to train a model from the ground up. But right now, you see that more and more people are just using inference rather than just doing training. And you may think about why there's a shift. Why there's a shift? I will answer you later. But there are some facts that shows that the inference is getting more and more important. Around a few years ago, from NVIDIA's forecast call, they share that not so many people there are doing their inference, but just around 2024 Q4, they share that the inference workload raised from 0% to 40% in just a few years, and they see more and more people they are doing inference. And I'm going to ask you, why you think the inference getting more and more rather than just training? Anyone got any thought? Sorry? Exactly. And any other thought about that?
It's just cheaper to do it.
Yeah, of course, yes. Sorry. Quality.
Yeah.
Of course, yeah. Here's my thought, because at DigitalOcean, we do get a lot of requests from customers about training versus inference. As a solution architect, we need to understand why you really need a training. Maybe you just use an open source model. Here's what I'm thinking. Not so many companies, they got enough data to train the data or to train a model from the ground up. The data is not enough for them to create or to build up complete new models from the scratch. And most of the people, they just use the existing data with the open source model and just use the RAG to apply for it instead of just train it. Some companies, they just use data to just fine tune, but it's a small portion because the current model, either closed source model like ChatGPT or Cloud, or open source model like Queen or DeepSeek, they are very capable. So they just rely on this model to do inference with the existing data. So when you think about what I just talked about and some other audience while they share, you may think about, all right, it makes sense because training is more like a one-time investment. From our perspective at DigitalOcean, most of the people, they think about GPU, like a H200 is really expensive. So they just spin up the server or a bunch of the server, and they train, and they close it. And when they say close it, they terminate the resource because it's so expensive. But when you think about inference, every API call, every integration or every thing that you integrate with existing inference endpoint, this is where your revenue comes. So it should always be online. As a result, inference is getting more and more, let's say, get higher attentions rather than just training. So with this trend, you may think about, all right, so what does that mean to you? What does that mean if I want to create or build up a AI native SaaS? So if you think about you want to get like as a next very hype or next unicorns, you also need to think about, is the AI infrastructure ready for a large-scale inference? Because what I'm going to share is a true customer story that their success become their largest nightmare because they grow so fast. So actually, I would also say this is a good problem to have because you are going to be very successful, but your infrastructure is not there yet. So here's what I'm going to tell you how you can solve it with some open source tool. So here is the, let's say, anonymous customer story. It's an AI unicorns. Let's say their use case is AI partner. To be more specific, like an AI girlfriend, AI boyfriend. And for this type of use case, it is very important about the user experience. For example, how many of you will do some consultation with ChatGPT? Like, hey, how can I solve my marriage issue? Or, not just kidding. Or how can I best planning to visit from Munich to London with a baby, something like that. So you use this ChatGPT or the model as your consultant. This use case is that the users grows from 1K to 100K just in 6 months. And the cost obviously grow like proportionally from 5K to 150K. But that makes sense because you need to do a lot of inference. But the worst part is about the performance. At the very beginning, the response is very fast, 200 milliseconds. How are you today? It's just reply, I'm doing well. But when it grows to 100K users, you need to wait like 8 seconds to get a response. Like, how are you doing today? And your AI girlfriend just responds, I am fine. The experience really, really sucks. And probably next time you will say, what are you doing? Instead of like, how are you doing? Because the user experience in this type of like, emotional AI apps really matters. So even though they grow so fast, but their infra is not there, it's not ready yet. And if you take a closer look about why it happens, because we're still treating the AI workload in the traditional approach. For example, on the left-hand side, your left-hand side, the modern HTTP request, each request represents like a square over there. If you think about it, the payload itself is actually defined by the user interface. You create the front end, the user interface. You define what parameters you can put in, and you also define like the largest size of the request that can send over to the backend server. So it's predictable. On the right-hand side, LLM request is very dynamic. Sometimes you just want to ask them to do summarization from a whole meeting note. Sometimes you just want to do translations. But right now we are more demanding about the models. We will ask more open questions or some question that involve a lot of reasoning. Like for my case, I need to bring a baby from Munich to London, and we also have a car seat and a trolley. So maybe I will ask them, hey, can you tell me what is the best route for me to fly from Munich to London with a baby under 1 year old? Tell me everything. So it's involved a lot of context. what I want to say is that since we are using more like a dialogue approach to communicate with the model, so you cannot really define what kind of payload you want to put in. As a result, it's vary a lot, like this one. Sometimes the payload is just a small, sometimes very large, sometimes medium. It cannot fit, it cannot fit one size. If we're using a metaphor or like a knowledge about, so what does that mean? Traditional web applications request is like, just think about like you go to fast fashion, like Uniqlo. The clothing already be standardized with large size, smaller size, medium size. And you just check what you want, or sometimes you ask the Uniqlo people about, hey, do you have this size? You don't need to know this guy. They will just tell you, oh, yeah, we have it, and give me the money, bye-bye. But AI workload is more like go for like a tailor suit, like you go to the basketball tailors. At the very beginning, he needs to understand the ratio of your body, your upper body versus your down body, and understand your advantage of your shape, and try to make sure that the suit fit for your shape as much as possible. So, and sometimes you will also have some personal relationship with this tailor because they know you a lot. The difference is that the tailor understands you. This means the context. At Uniqlo, they don't need to know you. So one is a stateless, another one is more stateful. And because sometimes you go to a tailor, you want a whole new suit. Sometimes you just want to tweak a little bit about the length of the charger. So it's vary a lot about the request. Does that make sense? All right. So what I'm going to tell you is that there's an open source framework that is dedicated to handle this situation, especially for the production levels of the inference workloads. It can increase your GPU utilization rate and reduce the inference cost as much as possible and scale horizontally and just deploy in 15 minutes. So at the end of today's talk, I will give you a pre-recorded demo about how you can deploy this solution in 15 minutes, not just in 15 days. All right, before we get started, let's give a quick crash course of inference process. How many of you are familiar with inference process? All right, 1, 2, 3. So you guys familiar with this process? Probably, okay. Some people nod your hand, some people don't know. I will give a very quick crash course. So let's say, I don't have a pointer, but it's okay. When you put in your prompt, like, please translate this word, this conversation into Chinese. All right, so the next part is that tokenization. Tokenization means that translate the human language into mathematics expressions so that the machine or the model can understand that. So it's called tokenizations. And then let's go to prefill. Prefill is like you tell them the context, like who you are, what are you doing, or anything that the model needs to know before they start to generate the response. So prefill is the second important phase during the inference. And then the decode is that it will start to create a token by tokens by just regressive predictions from the previous generated tokens. So this is a decoded session. And then after you get the response, at that stage, this is still in like mathematical expressions. It's a need to do detokenization, like convert into like English expression, and then send it out. What I want to emphasize is that each phase, each of the, let's say the prefill, decode, request different hardware resource attentions. So during the prefill phase, it requires a lot of GPU resource, especially the computing part. to do conversions. And when the request be created, and then it will send over to decode, and it will request another resource on GPU cards. It is a memory. So what I want to say is that in a GPU, you will have the computing resource and also the memory resource. But sometimes if you're just using a single GPU card, when it's doing prefill, one resource, like a memory, is idling. When it's doing decoding, the computing resource is idling. So it is not, the resources are not always fully utilized. Everyone knows that GPU card is very, very expensive. And you will not just waste some spare time for it. So this is where sometimes the GPU utilization rate is not high enough. So you always want to keep them very busy. But if you are not using more like a contemporary framework, there will definitely some waste. So what I want to introducing is the framework called LLMD. This is where you can really think about LLM inference. The first highlight for this framework is called disaggregating serving, which means that it will disaggregate prefill and decode into separate hardware resource, which means that when you get a lot of AI workload comes in, it will allocate specific pod to do prefill dedicatedly on that GPU resource. And when it goes for the decoding, it will fully utilize the whole GPU resource, the memory part, just to make sure it is very busy. And the second is that it is Kubernetes native. So if what I saw is that most of the company, they deploy their AI kind of like a backend on Kubernetes. So this framework is already be designed for the Kubernetes. And the third one, smart resource management. Another speaker, Jack Pearce, he will do a demo, tell you how does a different scenario showcase a different result based on the smart resource management. And last but not least, production ready. I saw there are so many companies, they are already adapt LLMD as one of their inference framework. And I will tell more later. So very quick overview. So when we use an LLMD to create, to serve the resource, to serve the request, it will first go to the gateway. And the gateway will understand, all right, this type of a request, and then we'll go to inference scheduler. The inference scheduler is where the magic happens. It will decide which underlying pod should serve the request. Either it is a prefill, or it is just decode, or you need to use both. And then when it goes to the cache and come back, it will try to find which right pod should process in the request. I know it sounds very vague, so I will introduce Jack to be on the stage to give you a more specific demo about how does this inference scheduler they're working behind the scenes. All right, so please give a big pause to Jack Pearce. He's going to show us how does the magic happens. Stage is yours.
Thank you. Hey, folks. So I'm in the same team as Jeff, solutions architect at DigitalOcean. So we've spent the last year, maybe year and a half, with customers deploying workloads on Kubernetes with both NVIDIA and AMD GPUs. So something that we started using as like a visual demonstration. Jeff, will it just come straight up, the actual?
Oh, no, sorry.
Okay. Sorry, just technical difficulties. 1 second. So whilst Jeff just brings that up on the screen, what I'll show you is a visual demo tool that was just created by this guy, Christian. And it just gives you a quick visual on how LLMD is scheduling different types of workloads to different pods on a Kubernetes cluster, essentially. Ah.
Oops.
Cool. Yep, thank you. Okay, so essentially this visualizes sending different types of workloads to LLMD. So if we take a look at the first example, you'll see it run through the scheduling process. What LLMD is doing is it's intelligently deciding which pod and then essentially which GPU these workloads end up on. It doesn't do it in a round-robin fashion. It will consider things like the length of the prompt, whether it's already in a cache, the load of that GPU, and then also whether or not an existing user session has already gone to that GPU, and then obviously filled the cache, which results in a faster response because it's very memory intensive having to decode a large response all over again. So yeah, when we take a look at this, this first scheduling, this is just a very, very simple example of a short prompt. So it's like, hello, how are you? You can see that 5 tokens, that's under our 100 token threshold for where we would actually split the work. So one single pod just handles that. It goes to decode only capable pods, and it gives it a score based on the queue depth. So basically how busy is that pod and how busy is that GPU at that time. And then whichever one is least busy ends up serving the workload. For something like a long prompt, that's where we will use this disaggregation. And let me just do this on repeat. So this is a much longer prompt. This triggers the prefill, decode, split, essentially, where we split the workload between multiple pods. So you can see that for the decode, VLLM decode 2 is selected, and that's because it has a low queue at the moment, and also 40% of the prefix matches the cache. And what that means is that, let's say, for example, your prompt starts with, so in this example, you are a helpful AI assistant specialized in. So that prefix has already been cached. So you can imagine, lots of different examples there. And then for the prefill pod, 60% cache match, and yeah, you can see that the workloads get split between those pods. And then in this last example, we have session affinity. So with session affinity, you can imagine that there is an ongoing conversation with a large language model. And when we run this animation, we can see that it's small enough to fit on a single pod. And as part of the request, we're sending this header, so part of the session token, so it's an existing user conversation. That token is then matched to an existing decode pod where the cache and the conversation already exists. So it's not having to run that through memory again. It's very memory intensive. Yeah, and then the conversation continues from there. So essentially, this is just an example of how LLMD is routing the requests in a more intelligent fashion, essentially to distribute the workload better and just speed up the end result. So yeah, that's that very quick visual demo that we started to use on customers to help explain things. Cool. Back to Jeff.
Thank you, Jack. Wow. I need to be honest, this demo is not created by DigitalOcean. This is a demo created by Christian Posta. He is the field CTO at Solo.io. He's so generous to allow us to use this demo script to showcase how does the LLMD scheduler they are running based on different scenario. All right, so let's come back to here. Okay, so here comes to almost like not the end of the presentations, but about like the demo part. So what we are going to show you that how you can install and run some example workload on LLMD. We are doing that on our DigitalOcean's management Kubernetes. Since we are working on DigitalOcean, we got a free resource to use GPU, but I will skip this part very quick. It is not that important. But one more thing, we got GPU, NVIDIA, and also AMD GPU available if you're interested. So here comes the deployment demo. The first thing that I want to say is that just last year, around October timeframe, we already submit the DigitalOcean's Kubernetes setup at LLMD's official GitHub repo. So if you are interested to deploy some very basic setup with LLMD on Kubernetes, you can find it from this link, GitHub/LLMD/LLMD. And if you are more like you want to learn by yourself, you are not like a video learner. Oops, what happened? All right, good. We also got a tutorial ready for you because DigitalOcean is, what DigitalOcean is really good, or what we are trying to contribute back to the community is about this tutorial. So you can find everything from this tutorial, and it's written by DigitalOcean. So from zero to production in 15 minutes, 4 stages. First one, set up the GPU Kubernetes clusters. The second part, deploy the LLMD stack. The third one, set up the monitoring stack. Sorry, I'm a little bit getting weight recently after I come back from Taiwan. So with the monitoring stack, we can indeed see whether when we hit the endpoint to see the performance, like the latency, time to first tokens. So let's get started. So let's get started, and let me swap to this part. My name is Jeff. I'm a senior solution architect at DigitalOcean. Today, I will deploy a distributed LLM inference platform using LLMD on DigitalOcean Kubernetes services. And everything can be deployed from zero to productions in under 15 minutes. So let's get started. First of all, let's go to this GitHub repo and then click the quick start. Under the infra folders, there's a DOCast DigitalOcean. This is where we will get started. Once you clone it, go to your IDE to run a script. Okay. So for me, I already cloned it, and I'm going to deploy the very first GPU clusters. Our GPU cluster will consist by 4 nodes, 2 CPU nodes and 2 GPU nodes. We will use the RTX 6000 ADA as a starting point. Let's go to the quick start in front digital. And inside we have the script. Let's set up the GPU cluster.sh. If we have a -c, then we will create a new cluster. So the script itself will detect whether you already have the GPU clusters running. If you don't, we will create a new one. So on the right hand side, this is my DigitalOcean's account. So let's refresh, and then we can see there is a cluster it's been creating at this moment, and let's click through that. And let's go to the resource part. You can see we are building a CPU pool. It may take a couple of minutes, so let's make a pause here.
A few moments later.
Okay, from the screen you can see that after around 3 to 4 minutes, we got the first CPU pool created. The next part, we will create a GPU pool automatically. So let's give a couple more minutes to spin up these 4-node Kubernetes clusters.
A few moments later.
After like 6 minutes, we got the GPU pool created with 2 GPU nodes inside. On the left hand side from the terminal, you see that the script got terminate or timeout. This is quite normal because we need to wait while the script keep waiting until it's timeout. Don't worry, just rerun the script. And this time let's just remove the -c. It will first analyze the current clusters to determine whether the pool has already been created. If it is already created, it will start to install NVIDIA device plugin so that we can utilize the GPU resource together with some container runtime. Right now everything is finished, so we already have the first GPU cluster being spun up on DigitalOcean. After we finish all those installations, we can do a quick checkup about our node status. So let's use kubectl get node with this label, GPU brand NVIDIA. And then we found there are 2 nodes in here. We can also describe the node just to ensure this is indeed equipped with the GPU. Yeah, perfect. So let's go to the second part, the most exciting part. Let's deploy the LLMD. So the first thing is that you need to ensure you have the Hugging Face tokens being exported into your environmental variables. Right now I already export my Hugging Face tokens. So I will just use this command to deploy. So let's see. Yeah. So right now the script cell will start to detect whether the necessary environmental variables are all being set up in the environment. Once it has, it will start to install everything. The first thing is that it will start to prepare gateway. In here I use the ECTO. And then it will start to use the Helm to install some other dependencies. Let's give it a couple of minutes.
A few moments later.
Okay, so after like 2 or 3 minutes, the script itself is running through successfully. And if you run the script, you can see all those login informations indicate the current installation process. If we scroll down, it will first install the GAIE CRD, the custom resource, and also start the gateway ECTO. After that, it will start to check whether the namespace LLMD exists. If it's not, it will create Hugging Face secret just to access the models that we've been granted, and then create another CRD model service. When we scroll down a little bit more, there's a service monitor. CRD will also be installed, Prometheus and Grafana, and then everything will be deployed successfully. Let's give it a try to see whether the pod is ready or not. Perfect. So I do run a couple of times about kubectl get pod in this namespace MD. It may take some time for model being pulling into the node. So you can see sometimes the pod is
under initialization and a container is creating because they are downloading the model. I think around 2 minutes after the pod being spin up, everything can be run through very smoothly. Okay, the last part is about the monitoring. So let's go to the monitoring folder. Okay, let's see what we have. And then let's set up the monitoring dashboard. So we still need to wait a couple of minutes because in this part, we will also import some dashboard that is dedicated for the inference gateway so that after we test the endpoint, you can see some metrics showing up in the dashboard. Let's give it another couple of minutes. Okay, perfect. We just finished the monitoring stack installations and let's give it a try. The first thing is that we need to run this port forward command. And let's go to the Grafana. The account and password will be shown up here. So you can just copy and paste and log in. Oh, sorry. There are some typos. So let's go to the dashboards. And Inference Gateway is the one that we want to have a look. Alright, so right now we already create the GPU cluster. We deploy LLMD on top of that. And also there's a monitoring dashboard. Let's start to test it. So let's use another terminal. And let's run this test script. It will test against the endpoint. It will automatically detect the endpoint of your Kubernetes clusters. So let's just use it. If you're interested about what they are doing inside the script, just go look into the script. This script will test 4 areas. First of all, it will fetch available models from the decode pod. And then it will send a check completion request to its decode pod. For example, it's I'm your friend, you are confident, your partner in crime, blah, 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 and waiting for the response. And then the third one will fetch available models via the gateway. And the last part is about sending a completion request via the gateway. So overall, everything test complete. And let's go to the dashboard. That's 5 minutes and we'll refresh automatically. So as you can see, there are a couple of the token throughputs and all the metrics are here. We just quickly set up everything in under 15 minutes and also test against the endpoint. If you are interested about how to optimize the model's performance, we will have another episode to talk more about that. Wish you like today's demo and have a fantastic day. Thank you.
Wow. It's clear, everyone? Sleepy or awaking? Well, for me, I watched this demo for like 20 times. Sometimes it's really, really hard to listen to your voice directly. So yeah, sometimes I feel a bit embarrassed. Oops, where's my... Oops. Yeah, I try to find DigitalOcean's. All right, now this one. So let me just redo it again very quick because we are going to be the end of this session. All right. So just a very quick recap over the past 10 minutes. The first part, we just deploy a Kubernetes cluster with GPU underneath. This stage is very, very important because when you try to deploy a GPU-enabled cluster, you need to make sure the driver is there, like the voice plugin. Otherwise, when you spin up the pod that requests GPU resource, it will just tell you no available resource. And you will start to troubleshooting everywhere until you understand, all right, you just don't have enough or necessary driver. And the driver version is also very important because a lot of customers, they're stumbling upon this point for like a couple of days. So this is why that we try to make sure this is sorted out at the very beginning. The second part, LLMD stack. The third part is the monitoring stack so that we get a visibility, what we are testing and whether it is hitting the right endpoints and get more clarity about what you got from the performance perspective. The last part is doing the gateway testing, retrieve what model you have and go through the gateway or just hit the decoding part directly. So this is what we go through over the past 10 minutes. So here comes the last part. All the demo, all the script that you see, it is available online. So what I would suggest, just take a picture for this part. There are 3 QR codes. So if you're interested, you want to just take a look, just scan one of it. And if you are already using LLMD or not using LLMD, but you have some AI workload you're interested, we're happy to help, no matter you are DigitalOcean's customer or not. So thank you so much for your attention over the past 15 minutes. Appreciate for your attention. Thank you.